Let's get started on the first of our function exercises. Okay, so we'll just copy the prompt that my colleague generated. We'll put that over here. And the prompt is, write a program that calculates the factorial of a given positive integer using a function. And I already observed in this week's introduction that this is pretty similar to the exercise from last week that it suggested for loops. And because of that, I'm not going to go into too much detail about like what a factorial is, because you can go watch that other video for that. But just the quickest reminder, if I ask for the factorial of a number, so if I ask for something like 5 factorial, that would be the product of every integer, every positive integer less than or equal to whatever I'm taking the factorial of. So 5 factorial would be 1 times 2 times 3 times 4 times 5. And notice how just like last week it says positive integer, which means I guess my function doesn't have to worry about what happens if you give it a negative number. We can sort of ignore that. We can assume that the caller of the function is passing you a positive integer, and if they aren't, that is their fault and not yours. And I think it's reasonable also to assume, just like we did last week, that if you give me an integer, if you ask me for 5 factorial, and 5 is an integer, then I'm going to give you back an integer. The actual value of the factorial will be an integer. Now, the exercise doesn't give very much detail about how the program should work, but I have a pretty good idea of what it's probably suggesting. So what it wants is a main function that calls this function it's asking me to write, because this is supposed to be a function exercise. Okay, so I guess I'll make a main function where I come up with some value I want the factorial of, so we'll call that input n. And then I'll print out down here the factorial of, and then I'll print out the thing I'm taking the factorial of, is this. Okay, so I give input n as the first thing. So the factorial of, let's say, 5 is, and recall, as it turns out, that the factorial of 5 is 120. So then I'll call my function, and I'll pass in the value of my input n into the function. So factorial of input n. I'm deliberately calling this thing input n and not n, just so that there's no confusion when I want to use the variable name n up in the function. Although, of course, I'm allowed to use the variable name n in main and anywhere else I want. There can be multiple things in my program called n at the same time. But just to clear it up for the sake of this exercise, I'm going to call it something different in main. Okay, and then up here, I want to write a function. So down here, I have called my factorial function. There is the call to the function. And maybe you can already see I'm expecting that this function I'm about to write is going to return an int because I'm printing it out using %d. So maybe that already tells me what my function signature is going to look like. It'll probably look like this. Int factorial, and then as an argument, I take int n. All right, and then I'm returning an int again because of the logic that obviously if I'm taking 5 times 4 times 3 times 2 times 1, that's going to fit inside of an integer. And now what I'm going to do is basically write the same code that I wrote in the exercise from last week to compute a factorial. The function's name is factorial, and just for the sake of making it more obvious what's a variable and what's a function, I'm going to store the data. So when I actually compute the factorial, I'm going to store that in a variable called the factorial. And we'll start that at 1. And just thinking back to last week's exercise, which I should add, I actually recorded yesterday, so I should remember this. I think the technique that I used looked like this. So what I'm going to do is, if you want 5 factorial, which is 1 times 2 times 3 times 4 times 5, I'm going to start with just 1 and then run a loop counting up 2, 3, 4, 5, and each time I count up, I'm going to take that value and multiply it into my running factorial as I go. So I'll start my counter at 2 because I already have 1 in there. Okay, so I'll write, well, my counter is less than or equal to n. And as I said, if you want to know why I'm doing it this way, go take a look at the other video. Then I multiply the factorial equals the factorial times the counter. And then I add 1 to the counter. We'll do a plus plus this time. All right, and then when I'm done, I want to return that factorial that I computed. Now, one quick note is that when you're writing a function like this, suppose you're writing this on an exam. This is a very nice exam size exercise. This is actually, I would expect on midterm 1, you'll see a few functions that might be longer than this. If you're writing this on an exam, one thing you ought to do is quickly trace through it. So pick a value for n. So in this case, maybe pick something easy that you might know the answer to already. already. So let's say it's pretty easy to compute 3 factorial. Pick a value for n, do a quick trace on paper just to verify that what comes out, what you end up returning, is indeed 3 factorial. Nobody ever wants to do this. When I suggest this to people, they always try to avoid doing it. They say it's a bad idea. They say there's no point. They say they can just look at it, and maybe you can. And in general, we're all actually becoming pretty good programmers here. In general, we are pretty good at glancing at code and sort of figuring out what's going on. The issue is if you have a bug, a tiny little bug somewhere, it's really hard to notice unless you pretend to be the computer. And although tracing a function isn't very much fun, I mean, it's going to take a few minutes, the more often you do it, the faster it gets. And the easier it is to do it, and the more efficient you get at it. Okay, so in this case, though, because I'm writing the code in Jupyter Hub, I could just run it. And if it works, then I suppose I don't have to try and trace through it by hand. So I'm going to run this with my input n set to 5. And what I'm passing in is the value of input n. And so I should expect if I change input n that I change the thing I'm computing the factorial of. So there's practice functions 1. The factorial of 5 is 120. And of course, the natural next question is, does that mean the program works? And the answer, of course, is, as usual, no, it doesn't. That means maybe I was just lucky. I have to do a bit more testing to make sure this program actually works. So recall from yesterday, or last week, I guess, that 4 factorial is equal to 24. And actually, maybe I can just draw a couple of, I'll just draw them over here for quick reference. So 3 factorial equals 1 times 2 times 3, which is equal to 6. 4 factorial equals 1 times 2 times 3 times 4. That's a pretty weird looking 3, which is equal to 24. And then 5 factorial equals 1 times 2 times 3 times 4 times 5, which equals, as we just saw, 120. Okay, so I'll try it at least on those, because that gives me a pretty good hint as to whether something is horribly wrong with this. Okay, factorial of 4 is 24. We'll try out 3, and then hopefully that works. All right, that looks like that works. And then I'm also going to try out 10 factorial. And we'll take a look at that. And just like I said when I recorded this exercise for loops, it does turn out, and you can check this, that this number is indeed 10 factorial. Okay, so I now am reasonably confident that my program works. I tried a few inputs that were close together, 3, 4, and 5. Those are ones I could check myself. I also tried at least one other one that's pretty far apart from 3, 4, and 5, and that one has worked as well. I don't have to try 0 or -1. I suppose I should make sure that I try factorial of 1, because we know that's sort of a special case. You can't get a factorial of anything less than 1, so 1 is the very first number for which you can compute a factorial. We better make sure we test that, and it turns out it's 1. That is what I expect. Okay, so I think I'm now done the exercise. I'm pretty confident if I'd written this code on a midterm or something and it looked like this, that this is correct. And I could test it by running it. I could test it by tracing it through by hand. Now, just like in the loop exercise, I'll make one more observation. So this is the extra credit part of this, I guess, which is, as we saw last time, if I try and compute the factorial of something large, then I'm going to end up getting weird behavior. So this strange behavior is really what's happening here is that the number I'm computing is bigger than I'm able to store in an int. And we saw that yesterday, or we saw that last week as well. Wow, I've got to figure this week and day thing out. So what we could do, just like we did last time, is we could change the types that we're using from int to a larger type. And if you think you're going to need big numbers, why not just get the largest type you have available? So for our purposes, in everyday practice, that's long int. You can get larger range ints than that, but we'll just work with long int. Now, it's not sufficient just to change this and to change this. Recall from the last video that I have to use %LLD if I'm printing out a long int. I also have to change everywhere else that calculation is happening. So when I compute the factorial up here in the function, I have to use long int. For safety, I might even want to use long int for my counter. It turns out that isn't really required, but I might as well do that. But also, I should be using long int as the return type. Because as the function is currently written, if I don't make any further changes, actually, why don't we try this out? Now, what's interesting is that the compiler is able to catch an issue here. This warning is basically telling me to go back and finish doing the thing I just stopped. But for the sake of the example, let's see what happens if I run this without making that change. And you can see here, this is not 20 factorial. strangely, it isn't the same value it was a minute ago. It's not negative 2 billion or whatever it was. It's some other value, but it's still not 20 factorial. And the issue is, in my opinion at least, we are actually computing 20 factorial correctly inside of the function. The problem is on line 20, I'm returning the value of this variable here, which is a long int. But my return type is int. And that means that when I send something back, it must be jammed into an int, which of course doesn't have enough range. And that's what the compiler is telling me here. It's saying, hey, you think you're printing a long int, but this function returns a regular int. And so maybe you're not going to get what you expect. So I have to make sure I change my return type so that I never use the regular int type. Now, I don't actually have to change this to be long int, but just in case, it doesn't hurt to use long int for literally everything to avoid having this mistake, because the compiler won't always notice it for you. Okay, here we have this, and I guess I'll do just like I did last time. I will actually go over, and on my other machine, I will check that indeed that is what 20 factorial equals. And just by a spot check, it looks like it is. So there's 20 factorial. Okay, so notice how when I needed to change those types, I had to change a lot of types, including the return type of the function. And that's because when I return something from a function, it will always be sent back using the type that I gave in the function signature, whether or not whatever value I'm sending actually fits inside of that type.